Hi, I wanted to give you an explanation of essential question number 5 during the fall of 2011. Essential question number 2, version 5 in the fall of 2011. And so it's another one of these time value of money problems. Let's take a look at the structure of this one that we have right here. We have something that looks like a linear gradient sequence going up. We've got a constant series looking thing right here, and then something that looks like a linear gradient sequence going down. So we see this has got a couple of parts. First thing is do this linear gradient sequence that we have right here, I'm going to break it right there between the 4 and the 5. That looks like a classic linear gradient series. It's just kind of off by 1. So the way I'm going to depict this is say that we're looking for the present worth of this thing. I have something which goes off by 1. So we're looking for P, given that we know G, whatever the interest rate is. We'll sort out what the N is. And I don't think we need to go ahead and shift this up, so we should be okay. Next, I have this constant series over here, so it's a bunch of 5s. And remember that trick about the linear gradient, having it always start at 0? I'm going to make it so that I am going to drop this linear gradient off a constant series so that it works out right for us. So I got a bunch of 5s. I'm looking for P, given I know A. Here's an I, and we'll figure out what the N is, and we know that we also have to time shift it. And then the last part is going to be this linear gradient sequence, this part over here that goes down. And so what we're going to do is it looks like it goes down by 2 each time. So we'll look for P, given that we know G, I. We'll figure out what the N is and the time shifting in just a sec. So let's go ahead and actually stick in all our N's and our exponents. First, this first linear gradient in the front, so I'll do some red. There's 1, 2, 3, 4 of these, and then we add 1 for the pot, so that gets us up to 5. Second thing is it's not where it's supposed to be. For a linear gradient to work, it's supposed to have 0 in time period 0, 0 in time period 1, and then it starts coming up with your G's. So for this one right here, if you take a look at it, the last time that we actually see something is in time period 3. So that means that this guy right here, the exponent has to be a -2. And if you think about it, if that's supposed to be time period 2 for the sequence, time period 1 should be -1, time period 0 should be -2. So that works out just fine. Now this constant series that we have up here that we're going to hang our linear gradient off, this right here is 1, 2, 3, 4, 5, 6, 7, 8, 9 long. So I'll put a 9 right there. And count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, I did count that one right. And it's shifted around a bit. It ends in time period 12. So I'm going to use that addition rule where the N and the exponent added together give you the last time period where you see a value 12. So I'm just going to go ahead and pop in a 3 right there. And that should be right for this line of constants that's up right here. And then let's drop our linear gradient off it. So this was the one that was going down by 2 each time period. So there's the first, second, third, fourth, fifth. Plus we have to have 1 for the pot, 6. And if I look at this sequence the right way, it looks like time period 6 would be like the relative 0 for this one. And if you do that math where you add the N and the exponent, you end up with the last time period, 12, when you see the value in the sequence. So that should be one of the ways of writing the present value of essential question number 2, version 5 in the fall of 2011. Thank you.